the thickness, I'm just going to call it T to power 3 divided by 12. Okay. And then I'm going to take the area 4 multiplied by thickness. Okay. Multiplied by the distance. So we know that from here to here, this distance is equal to 3. Okay. So this is for IZZ1, IZZ2, and then plus the width is 3. Okay, so this is for IZZ3. The width is T. The depth is 6 plus 2 plus 2 is equal to 10. Power 3 divided by 12. Okay. So this will be equal to 4.
Professor, I have a question.
Yes. Yes.
Shouldn't the base be 4 minus 1 over 8?
Okay, later on I tell you why we don't do that. Okay, later on I'll tell you why. Okay.
Okay.
So 4 divided by, so this will be twice. Okay. So this will be T cube over 3 plus by 12T. Okay. Minus plus by 10 power 3, which is 1000 T divided by 12. Okay. So once you get over here, okay. So I want to take note. So let's say note, okay, note that T is equal to 1 over 8, okay, inch. We know that now, right? Right? Note T is equal to 1 over 8. So why is that? Because it's over here, okay? So IZZ, now if we include the 1 over 8, okay, so twice, okay, so 1 over 8 power 3 divided by 3, 1 over 8 power 3 divided by 3 is equal to 1 over by 1536 plus by 12 times by 1 over 8 is equal to 3 over 2. Okay. And then plus by 1000 times by 1 over 8 divided by 12 is equal to 125 over 12. So this will be equal to 1 over 1536 plus by 3 over 2, right? Times 2 plus by 125 divided by 12 is equal to 13.41 418, okay, 418 inches to power of 3. Okay, now I'm going to, just now Mustafa say, Eugene, you did not take away the thickness. Okay, I'm going to elaborate why for this case we don't minus off the thickness. Okay, now what if now, okay, so what you can say is this value over here is very what? Right? It's very small. So if we leave, okay, if we leave this out, okay, if we were to leave the T cube out, okay, so let's look at leaving T cube out of the analysis. Okay, our answer will be IZZ will be equal to still 2, right? So this term over here, T cube over 12. Sorry, T cube over 3. We're going to leave it out. Okay, we're going to leave it out. We're not going to consider it. Plus by 12 multiplied by 1 over 8. right? And then plus by,
Gee,
yes.
I think somebody already mentioned it in the chat, but I think the 3 is supposed to be squared. And the first line is supposed to be 4t3 squared.
Oh, I think you are right. Oh, who is the student? Where are you?
It was Mira, but Jeevan mentioned it in the chat.
Oh, you are right. Okay, so two of you get 2 points. Okay, you get 2 points. You're right. I lost it. Okay, so square. I do apologize. Okay, so 4 times 4 times. Okay, so it's you're right. 4 times 3 times 3. Okay, so it's 36t. Good afternoon. Okay. Sorry, not funny. Okay, so over here, thank you for letting me know. So 36 times 1/8 is equal to 9/2, right? So I get rid of this. Okay, 1/1536 plus by 9/2 times 2 plus by 125/12. Okay, that is very good. So we get 19.417. Okay, 19.418 in fact. Okay, inches to power of 4. Okay, so now, oh, thank you. You guys tell me, or not, you'll be embarrassing later on. So now, so the width is still 4, right? T, then this is 3 squared, right? So plus by 125. So this is still 1,000 T over 12. This is the same. So this will be equal to 2 multiplied by 4 multiplied by 1/8 multiplied by 9, right? Then plus by 1,000 multiplied by 1/8 divide by 12. So this will come out by 2 times by 4 times 2 times 4 times 1/8 times 9 plus by 1,000 times by 1/8 divided by 12. So this is equal to 19.417 inch. Okay, so what is the conclusion from here? Anyone? What is the conclusion we can get from here?
If something's small, we can neglect it.
Yeah, well done. Okay, Iman, well done. So over here, if you see anything that's t cubed, you can drop this term. Okay, so why is that so? Because the t is 1/8 of an inch. Okay, now come back to Mustafa answer. He said, Mustafa told me, Eugene, why you, so if this is 4 inch, you should be minus, you should get rid of 4. So this will be equal to 4 minus by 1/16. Yes or no? Right? Right? Because the distance from here to here is 1/16. Right? So in TIN1 analysis, okay, what we do is we did not consider the thickness at all. I repeat again, we did not consider thickness. So what we consider is just basically lines. I repeat again, we just consider it as lines. So let me elaborate what do I mean by lines. Literally in English, lines means we just consider the structures as what? Lines. Right? We consider, if we already ignore the thickness, we consider the structure just lines, literally, just like this. Does that make sense? So now we're going to find the second moment of area of these lines. So we know that the distance, right, that this is our centroid. Right, and we know that the distance from here to here, this entire distance is equal to 6 inches. The distance from here to here is 4 inches. And the distance from anything else, and the distance from here to here, right, is 2 inches. Does that make sense? Okay, by the way, I'm just the messenger, okay? I'm being obedient. I just follow what the textbook teach me, okay? Anyone, any questions, please? Anyone? No? Okay. So now we know this. We found our second moment of area. And this is also, if you want to get rid of too much decimal point, you just express this in fraction. Okay, it's also equal to 233 over 12 inch to power 4. Okay, so we have set up the second moment of area already. Okay, so we also know that V, right, the shear force is constant at any section of the structure. Okay, so when I say this V, okay, I have to be careful. The V is the what? Is there a force given? Determine is equal to 2.75 times 10 to the power 3 pounds. Okay, okay, this is the pound force. Okay, this is the pound force. It's constant in any section of the structure. Okay, so now we are going to start drawing. Okay, the shear force direction. I repeat again, we will start drawing the shear force direction. And this shear force direction is very similar to your shear flow. Okay, it's very similar to your shear flow. Okay, so why we need our shear force in each section is because we are going to do what? We are later on, okay, later on, we need to use this force, right, to analyze the moment about point C. Okay, that's what we're doing now. Okay, so from here, we are going to we're going to construct our shear force. Okay, again, our shear force, okay, acting in each section is very similar to what? It's very similar to our construction of our shear flow. Okay, right. So like a broken tape recorder. A broken tape recorder. So we know the vertical force in the section is called V. Okay, we still call it. So we construct. So this is V. Okay, this is our V. So V is our vertical shear. Oh, sorry, our vertical force, right? So now we construct the rest. So the V over here. So again, the web controls the direction. Okay, so A will come here. Okay, then this will be in this direction, right? Below the centroid, okay, this will be there, and this will come out this way. Okay, so that is how we construct our shear force in each section. Okay, so we are now going to label this, right? This arrow over here, we're going to label it FBD, right? And then we are going to label this one F or FAB. Okay, so wait, let me see. Should we call it FAB or VAB? Okay, because it's vertical, we're going to call it VAB. Okay, and this is VEG, and the horizontal, this is FEF. Okay. So from here, we know that what do we know? Okay, so based on area, okay, based on area where the forces are acting, we know that VAB is equal to VEG. Okay, and then FBD is equal to FEF. And this is basically because of geometry, because the BD geometry and the EF geometry in terms of thickness